So this talk, we're going to kind of build the data centers from the ground up, talking about the data centers, the servers, the storage, networking, compute, control plane, as well as identity. Specifically, my goals that I hope you leave this talk with are kind of knowing how the Azure data centers are built from the ground up, kind of give you a behind the scenes view of what goes into the products and services that you may be using on Azure. Give you a sneak peek of where we're heading, some of the futuristic stuff that we're testing out right now and starting to push into the data centers. And just like my favorite part of this talk, just show you some really cool tech. I used to watch these videos. So I've been on in the CTO's office for about 5 months now. And I used to watch these on the weekend as like wake up in the morning, make some coffee and just watch these. Like usually this is a 90-minute talk that I'm condensing down into 25. So I might speed it up here in a little bit, but it's just a really fascinating video. Highly recommend after this, you can get the full 90-minute version. The most recent public one was from November at Ignite. It's called Mark Rozinovich Presents the Inside the Azure Data Center. So that's like the full version of the talk that I'm giving today. All right, so let's start with data centers, kind of the ground that we build everything on. So we've shown this slide a couple times, but we have a really large footprint of where we place our data centers in our regions. We're up to 56 now. We just announced Israel and Qatar that we're going to be opening up later this year. But let's take a look at one of our data centers here in Dublin. Here you can see the DB3 and DB4, two of the data center facilities, which have separate power, networking, storage feeds, so that way they're completely isolated from each other. We've realized that we ran out of space in those data centers, so we had to build out a little bit. So you'll see DB5 over here spanning the length of those two. And so that got us a couple more months of scaling up, so we had to make it even bigger. So now you can see DB3, 4, and 5 here in the corner. Then we added DB6, DB7, DB8, and we're clearing land for even more data centers. So the land that we're using for data centers is just growing like crazy. We can't keep up in some cases, and so we're just having to invest literally billions of dollars every year, like tens of billions, into clearing land for more capacity. In some places, we can't build out. We have to build up. This is what I like to call the Azure Data Center IKEA edition. So here in Singapore, we actually had to have a multi-layered data center because the actual real estate itself wasn't available. But when it comes to data centers, we're also very mindful about our carbon footprint and sustainability. You may have seen the recent Microsoft announcement that we're going to go fully renewable energy by 2025. And then fully carbon negative by 2030. And then we even promised to offset all of our historical carbon emissions that Microsoft has ever produced since our founding in the 70s by 2050. And our data centers are kind of a testament to that. We are investing heavily in making them more efficient than comparable data centers that you might have from a large enterprise, as well as we're the most efficient when it comes to any other cloud provider. And we're doing large solar and wind deals in places like Virginia and New Mexico, and that's only growing from here. One example is, you may have seen it in the news, Project Natick, where we're taking our data centers, putting them in capsules, and then sinking them under the ocean, which is, we're learning a lot from those. And these are by far our most energy efficient data centers that we operate. We found that real estate is cheap when there's all this ocean available to us, especially near the coasts. And that's also beneficial because a large percentage of the US, like over 50%, lives in a county or near a county near the coast. So we can reduce latencies by taking our data centers, shoving them in a tube, putting them under the water near New York, Chicago, and any other place where there's large bodies of water. And there are also a lot of other benefits that we found out, such as they have greater reliability. I'll talk about that in a little bit. But they're also safe from like those 100-year typhoons as well as predicted solar storms. Whereas if, say, there's a large solar flare that hits Earth, like all of the land-based data centers might be susceptible to that, but these underwater data centers would have that water shielding. So there's a lot of really cool benefits that we're just starting to look into. So here's a video of one of our capsules being sunk off the coast of, I believe, Scotland during one of our initial tests. We did that about 1.5 years ago, and what we learned is for every 8 servers that fail on a land-based data center in our control units, only 1 server will fail in the water. So we're seeing about a 12.5% failure rate compared to land. We thought that was temperature. Like our 3 control units were cold temps, normal temps, and steady temps. But we found that didn't matter. What really is helping us is a dry nitrogen atmosphere, along with not having humans like bumping it, messing with them all the time. So we're going to be taking those learnings and putting them into our land-based data centers as well. And later this year, we're going to be pulling up this capsule to see what the erosion looks like and kind of what's inside of that. All right, so now that we've kind of talked about the data centers themselves, let's start putting inside the actual servers. So this is one of my favorite slides. So let's rewind the clock back about 10 years to February of 2010. The servers that we were putting into our data centers were what we considered to be powerful servers at the time. They had 12 cores, 32 gigs of RAM, and the industry was heading at the time in a place where we thought it would be kind of middle tier to low cost hardware, but in scale, where you could scale out your applications and everything was app service based. We didn't really foresee the large need for virtual machines. So this was what we put in our data centers. But then we realized that customers wanted to do more lift and shift, so we introduced what we called Godzilla. And this is 32 cores and 512 gigabytes of RAM. And so this was like the Frankenstein machine of, let's just throw as much power as we can into a box and put this into our data centers. We went from 2 gigabyte networking to 40 gigabyte. But then we quickly realized that customers had even larger workloads. So we introduced Beast, which had 72 cores and 4 terabytes of RAM. A lot of the SAP HANA was pushing these large workloads where we needed just insane amounts of RAM. And then from there, we started our more general purpose. These are the millions of servers being pushed out to all of our data centers. Intel Gen 6. We also started introducing AMD as well, and putting those both into our data centers. But then we found out that we had even larger customers. So we did Beast V2. This was, again, led by SAP HANA and some of these large lift and shift operations. So we threw in 224 cores, 12 terabytes of RAM, letting customers really max out their workloads there. So then as we started improving and making more efficient machines, we had Intel Gen 7 as well as AMD Gen 7. And so these are most of the virtual machines that you spin up or run on these two. And then a couple months ago, we started testing out like how big could we get. So now we have Mega Godzilla Beast with 448 cores and 24 terabytes of RAM. So that's in testing right now. And then on the IoT side, we also have Azure Sphere, which you can kind of see maybe down here. If not, here's a little magnifying glass. It's 64 kilobytes of RAM and 2 core and 4 core. And so this is what will be driving a lot of the IoT and Azure Sphere Linux operating system. And you can fit, I don't even know how many IoT spheres into a Mega Beast. All right, so just kind of now talking about what we put on top of these servers. We have our general purpose VMs. These are our A series and D series. This is more what your workloads would typically go on. There's also burstable. If you have jump boxes or things which sit idle for long periods of time, we have virtual machines when they're not in use and don't use CPU cycles, gain credits. And then when you go and use them, you can hit the max performance of them. But then once the credits are used up, you'll then be throttled. So these are great if you have short bursted like batch workloads and things like that. We also have GPU VMs with NVIDIA and AMD GPUs attached to them. If you have to do any sort of rendering or processing, if you're familiar with Windows Virtual Desktop and some of like having your developer workstation up in the cloud, we now have GPU partitioning where you can take a single GPU and cut it up into 8 to 16 different pieces and get fractional pieces of that as well, depending on what your workload needs are. And then there's high performance computing. If you want to throw some of like the most complicated and processor and memory intensive workloads on there, we have our H series. But then if there's very specific workloads that you have that may be really compute optimized, we have our F series. If you do more memory operations, there's M. And then storage is our L series. And so we allow you to be able to pick from any of these depending on what your workloads are. And then one of the things kind of looking forward from here is how do we cool these servers? Traditionally, I've air cooled. Another thing we're looking into is microchannel cold plates. This is what you would typically do water cooling on, say, your gaming PC at home, where there's a metal plate with water running over it that's on top of the CPU. We're also looking into one-phase immersion, taking, say, like a mineral oil or a liquid with a high thermal conductivity and dipping the entire motherboard in it and cooling our servers that way. And then there's also two-phase immersion, like dipping the entire server itself into a bath of liquid, which can cool our servers much more efficiently. So this is things that we're researching and looking into right now. All right, networking. I won't go too deep on this, but just to kind of give you an idea of one of the competitive advantages that we have over other clouds is that with like AWS and GCP, a lot of their traffic goes over the open internet when they go from, say, US East to US West. Microsoft has a huge, what we call a dark fiber backbone, where all of the traffic from one data center to another goes over the fiber and networks that we own. So in that case, we have lower latencies. All the data doesn't go over the public internet, so better security in that case. And you may have heard the Mira cable, or the cable that was just a couple years ago put over the Atlantic Ocean with the co-ownership between Microsoft and Facebook. That's an example of one of the dark fiber cables that we own. And if you zoom into like one of the regions, you can see in and out of a data center, there's multiple paths of fiber because we believe in redundancy. Azure experiences anywhere from 5 to 10 fiber cuts per day. And so we need to be able to have multiple ins and outs from each data center, especially within a region. So kind of diving into that a little bit, that what I just showed with all that cable is kind of this line here, this Microsoft Wide Area Network, or WAN. And connecting those are our edges, where we can do express routes and directly tie fiber into like a large enterprise if you have specific needs in that case. But we also do internet peering with things like CenturyLink or Comcast. So that way you get the lowest latency possible depending on your internet service provider. And then going into a region, we have our regional network gateways and our data centers with redundancy on multiple paths. And so each region has multiple network gateways. So that way if one building, due to a fire, tornado, or whatever goes down, the building next to it, like I showed earlier in the Dublin data center, still has availability. In terms of like what that means for you, we have a lot of different network products that you can take advantage of, especially in the space of security. I spent a couple years in security, so I always tend to veer that way when pitching Azure. There's things like distributed denial of service protection. You can have web application firewalls, Azure firewalls, but you can also take your Azure resources and put them actually in what we call a virtual network. So you can take databases and storage accounts and put them in your virtual network so they're not open to the internet. Similar to how you can take like a blob store and put it behind a virtual network. And now we're introducing things like service endpoints and private links. So your key vaults and your SQL databases, things like that, can only access what's in that virtual network. So you can control from the Azure portal or via the SDKs or CLI who and what has access to your data through microsegmentation. Definitely recommend checking that out and don't open up your resources to the internet. Control plane. This used to be the compute section, but Jen did an amazing job on compute, so I quickly rebranded it to control plane. And so with Azure Resource Manager, this is the full control plane of Azure. Everything sits behind this. So sitting on top of the physical servers and the hardware managers and the infrastructures are things like role-based access control, activity logs and telemetry, ARM configurations. And then sitting next to that are all our resource providers. Like when you spin up a virtual machine, that's the compute resource provider. Storage is the storage network provider. Networking is networking, et cetera. But then we also have higher level resource providers like Service Fabric, Azure Kubernetes Service, IoT Hub. And then there's also other RPs. You can write your own, like a custom resource provider to fit in with Azure Resource Manager and get all of the benefits of our APIs and our activity monitoring and telemetry. And then we make that available via the Azure portal, command line, and PowerShell and SDKs. So anytime you spin up infrastructure or submit a deployment, it goes through Azure Resource Manager, which then goes to the resource providers, which does the work of provisioning your resources. And unlike a lot of other cloud providers, all of our subscriptions, resource group, and metadata about your resources flow from region to region. So like if you're in our portal, you don't have to keep dropping down the toolbar to change from US East to US West and try to get that overall view. You just go into your subscription and you see everything. So even if a region were to go down, you can still see everything that's in it. So that's one of our differentiators as well. And kind of backing up a little bit to like that overall view of Azure Resource Manager, this has been the traditional model. But as we talked a little bit about earlier, we also have a piece called Azure Arc, which extends Azure Resource Manager and a lot of the management capabilities down into your own like locations. If you have Kubernetes clusters or servers or data services that you want to run and have more control over on your side, you can do that as well. So you can spin up your own like virtual region like within your own data center if you wanted to do that. All right, identity. As I mentioned before, role-based access control is kind of the key to how we handle who and what has permission to which resources. And so we always follow the pattern of least privilege. You don't make everyone an owner on your subscriptions, and you don't make like the dev team owner on like all of the finance and marketing team's resources. You do segmentation, making sure that people only have the access that they need to do their jobs and nothing more. So for example, you could have a user access administrator on the top who gives out permissions. Then you might have owners of resource groups, and then you might assign readers to specific things depending on how your organization is set up. You can also create custom roles. You can have a role where you can start VMs but not stop them. You can see that a Cosmos DB exists, but you can't actually read the data that's inside of it. So there's a lot of really like fine tuning that you can do on there. And it's not just for Azure Resource Manager. Take a virtual machine. If you're a reader on a virtual machine, you can see that it exists and that this isn't within the resource group, say deployed in the US West. But we also have data plane role-based access control. I can assign myself a virtual machine user login to that virtual machine, and now I can just go log into that virtual machine as my account within Azure Active Directory. So we're extending this whole concept of role-based access control into the resources themselves for things like database reads and writes. And combining that, we also have a thing called managed identities, because as you're developing your applications, you might have spun up, say, a database, and you might have like a shared access key or like a credentials URL or something like that. What we're switching to instead is actually assigning an identity to the application. So instead of, say, taking that shared access key, putting it into your environment variable or deployment file for, say, like an Azure function, you actually just go into the Azure portal or through the command line and say, my Azure functions is an object within Azure Active Directory. And then I can go into the database and say, this Azure function can write data into the storage account, or it can read data. So then even if you were to go steal the code, like there's no key to steal. It makes your applications that more secure. And when you're developing your applications, there's also a library that we created. So when you're developing locally on your laptop, it uses the user's permissions. So if I'm on my laptop, I'll go to test out this Azure functions in the emulator, and it'll use my credentials to go access the database. But then when I deploy it into the Azure function, it'll switch over to using the managed identity of the Azure function. So that way I can be like a contributor or owner on the resource group. And then I can make this Azure function a fine-grained role-based access control as like a database writer. And that's all it needs. So that way, if someone were to like theoretically take over your Azure function, they couldn't go list keys or dump things or do other things like that. So Azure Managed Identities is definitely a game changer in terms of securing and configuring your applications. And we also combine that with privileged identity management. This is something that we've used internally at Microsoft for years that we're making available as a product, where when designing your architecture, you don't want to give everyone like write access to your production environment all of the time. Like people get phished, people lose their credentials. You want to be able to gate their access to your production environment for, say, something like deployment behind approval. So if I want to go deploy my code into the production environment, I have to go submit a request into the privileged identity management portal. My manager has to go approve it, or someone from my team. And then I'll be able to go submit the deployment and actually affect our production environment. So that's another really powerful tool. And just to wrap things up here, the last section is storage. And I made sure to make it a little bit different than the other presentation because Rena did an amazing job earlier as well. So just to quickly give you an architecture view of how storage is set up inside of a data center. It's all based on the actual hard drive, solid state, and tape itself. And then they're created with clusters As we mentioned earlier, everything follows kind of the same storage levels, so that way there's not different monoliths for every file service. And then we have our different APIs here on the top, from file and table to NFS to SMB. And then within the data center, we have clusters, which are then that share the different layers. And we also then do geo-redundancy and geo-replication across multiple cluster groups as well. Here's an example of a new product that we're just starting to launch in private preview, which is the Micron Studio. We're actually partnering with our vendors to create special 3D NAND solid state drives. I didn't have time for a demo, else I would have shown you how this can achieve like 9 gigabytes per second read and write. And we are able to run things like SQL queries in like a fraction, like 1 to 5% of the time as a traditional NVMe solid state drive. And we talked about it a little bit, but Project Silica is taking pieces of glass and doing long-term archival storage. So an example is take a company like Warner Brothers, who has tons of media. They have these underground salt caverns where they take all of their film that they've created over the years and put them down there. But there's still risks of flood. Like there's been times when those salt caverns have flooded and they've lost decades worth of film. So we're partnering with them, and we actually have a glass with the whole Superman movie on it. So now they're able to write to these pieces of glass, and it can withstand floods, fires, things like that. And so then this will last for hundreds or thousands of years. So I have a quick video to actually show off this technology. This is a piece of glass that we wrote some data to. Don't do this with your actual hard drives and tapes. And yeah, we were able to read the data back without any data loss at all. So this is an example of kind of some of the forward-looking technologies that we're introducing into Azure. And with that, just kind of summarize, Azure is becoming the world's computer. We're trying to take a lot of the compute and a lot of the management and app development that you traditionally did on-prem and allow you to really focus on the business logic of your startup and of your application. Allow you to actually focus your time and efforts on things that matter to your business, and we'll take care of the rest. And so with that, I just want to thank everyone for your time today.